isosceles triangles. And if two sides of a triangle are congruent, then what else do you know?
That's the angles are congruent.
Very good. If two sides of a triangle are congruent, then two angles are also congruent. And this unit, this is where we're going to start adding all the stuff we've been talking about. Okay? If you don't use the right implications, if you don't write all the information that you know, you will not be able to solve the problems, and you're going to think that I'm making stuff up. Okay, I promise I'm never making stuff up. It's like those Sudoku puzzles. Have you ever done those?
I hate those.
And you think that people are just making up numbers and they never work? No, there's actually a pattern that you have to follow, and there's a way to figure them out. It's just not. Okay, so right here, if I have an isosceles triangle, those two sides that are congruent, they are called legs. The side that is not congruent is called the base. Okay? Is the base always on the bottom?
No. It's on the side.
In middle school it was, because that's what they showed you. Those are the problems they showed you. But up here we're going to be flipping and rotating and turning.
Ooh.
So if I gave you a triangle that looked like this, then this right here is my base. If I gave you a triangle that looked like this,
Pizza slice.
then the top is the base. Okay, so I want you to understand where the base is. Where the base is are where the base angles are, and those are your two angles that are congruent. Okay, so this is my base, so these two right here are going to be the two angles that are congruent. Because if two sides are congruent, two angles are congruent.
Then if two angles are congruent.
Two sides are congruent. Very good. Okay, so we have legs, we have a base. We then talked about the base angles being the ones that are congruent, right?
Yes.
This one up here is the one we haven't named.
The vertex.
It is the vertex angle. Now, some of you just got confused because we have a lot of ver words, don't we? Ver. We have a vertical line, like a basketball jumping up and down, right? Vertical. We have a vertex, which is a point. We have vertical angles that create an X and they're across from each other.
Vertical angle.
And now we have a vertex angle.
So right there,
There's a ver for everything. Vertical, straight up and down. Vertex is a point. Vertical angles are when they make an X and they're across from each other. And now we have a vertex angle. Okay, and that's the angle where the two congruent sides come together. Okay, so you're going to need to know the difference of each of those. Okay, we're going to keep talking about them. So now let's refer to this picture. Somebody tell me what kind of triangle is triangle QRS?
Isosceles.
Isosceles.
Isosceles of cube.
I would assume that it could be a cube.
You know it's
Okay? Then somebody tell me what are the names of the legs?
RS and SQ.
Okay? RS and segment SQ. Does it matter what order those go in?
No.
No. Make sure you put the symbol atop.
Okay.
What's the name of the base for triangle
RQ.
QRS?
RQ. Base RQ. Segment RQ.
Okay, without you calling it out, let everybody think. What is the vertex angle? What is the vertex angle? What? What angle? RSQ. Very good. Angle RSQ. I want to remind you, RSQ, when we're talking about the angle, is this angle right here. Could you have just written angle S?
Yes.
On this one, be careful. Okay? What's the base angles?
R.
RQS.
QR.
And angle what?
QRS.
QRS. Absolutely. Remember that your vertex is in the middle. Alright, now here's your challenge. I want to give you a couple of minutes and I want you just to look at number 1 and number 2. So it said that segment AC is congruent to segment AD, right?
Yes.
So what two angles are congruent?
Angle C and angle D.
Okay, I'm going to tell you, I would absolutely accept angle D, but if you write angle C, I'm going to count it wrong.
Why? Told you.
Why?
Angle EC.
Good. Are you talking about this angle right here?
Oh, Miss Ramsey.
Are you talking about this angle right here? Or are you talking about the entire angle?
The
Right
entire
there.
angle.
Oh, I want the entire angle, so how else could I name it to make sure?
AC.
Because I might tell you I'm going to give you $100, and then tomorrow I'm going to come back and just give you $1.
ACD.
AC.
Is that okay?
Yes.
If we miscommunicate, is that okay?
Yes.
No, I don't want to miscommunicate with you. I want you to know for sure what I'm talking about.
Yes, ma'am.
So I could call it ACD. That tells me for sure I'm talking about that entire thing.
Could you call the other one ABC?
A what?
BC.
ADC? Yes. A dog cat. Apple dog cat. Mhm.
The cat ate the dog.
Now that you're smarter, retry number 2. Now that you're smarter, try to retry number 2.
Angle.
So BE is congruent to BC. So what two angles are going to be congruent?
These two here. Angle.
BCE.
BCE
And
and angle
B.
And E.
E. C. Remember, the vertex is in the middle, correct?
Yes, ma'am.
Good. Now try 3 and 4. So now what are they telling me to do?
Look for the segments.
Good. They're giving me the angles because they give me this little symbol right here. So angle EBA, this angle right here, is congruent to angle EAB, which is this angle right here. So one of the things that people get confused is which ones are congruent. Well, what one side touches both congruent angles? BA, that's my base, right? So EB and EA,
I put AE.
that's fine. It doesn't matter what order you put those letters in. Okay? Then on the next one, it has CED. CED is this angle right here.
Wait, on ours we don't have an E.
You know?
No.
I did that on purpose. And then CDE.
What you mean on purpose?
I just picked who's I wanted to have an E and who didn't want to. I thought it would be fun.
Oh, we still with that triangle. I was at
We're
the
looking
bottom.
at the bottom.
Yeah.
Oh, no. Okay. And then, so here's the two that have the base angles, right? So this is my base. That means that these two are my congruent.
And DC.
CE and segment DC. Okay, now try another. So it says that AB is congruent to BC. If I have two sides that are equal, then I also know what?
That AC is the base.
That AC is my base. What does that mean?
That means it's angles are
Those are two angles.
Good. The angles on the base are congruent. Very good. If you don't put that, you cannot work this problem. If you just mark that these two are equal and you move on, you will not be able to solve this problem because of those two marks. That's how important they are.
That angle, this
Uh-huh.
one on this side is 40.
Okay, and then it says here that AC is congruent to CD. So which one's my base?
AD.
AD. So remember that my base angles
So I have a grid.
are going to be congruent. You see the differences in my marks?
Yeah.
If you don't put those marks, you won't be able to solve this problem.
Do we have to put the double mark?
Yes, because this one angle here is not the same as this one.
Okay.
Okay? And then it tells me that angle ABC is 80 degrees.
And what is
And it's asking what is ADC. What is this angle right here? Well, that's way over there. Okay, any ideas of where to start?
You have to do that one thing we did yesterday.
well, I mean,
You have to draw that straight down one.
Well, talk to me a little bit. What shapes are we looking at?
triangle.
Triangles? What do you know about triangles?
They equal 180.
Oh, they equal 180. Well, I have 80.
So,
So that one's gonna be 50.
180 minus 80 leaves me with 100, right? And that means that both of these have to be 100?
Yeah.
What do you know about them?
Congruent.
They're congruent, so what would you have to do?
The bottom in half.
Good, I cut this in half, which means that each one of them is going to be 50. If you didn't put those marks, you wouldn't know that, correct? Now what? Because that still didn't answer my question, what's this angle way over here?
I did, since, A, I mean, since B,
The other one is 130.
Good, this is a straight line,
okay.
so these two have to equal 180. So 180 minus the 50 is 130. So this one is 130, right? Now what? Good, now I have this other triangle, correct? How big is the triangle? 180. And I know that this one right here now is 130, which leaves me with 50. And what do I know about those two angles? So if I cut them in half, then I get 25. See how if I didn't put those marks, I wouldn't have been able to solve this, would I? Okay. Hey, somebody tell me what does equilateral mean?
Same.
What's equal?
Same.
The sides.
60, 60, 60.
So this means that these angles are going to be, these sides are all going to be the same. Well, if those sides are the same, what else can you tell me?
Yeah, all the angles are the same.
All the angles are going to be the same. What is it called when all the angles are the same? Angular. Notice the difference in the words, right? Well, how big are all the angles added together?
60.
No, all of the angles added together.
180.
180. How many are there?
3.
And if they're all the same?
It's going to be 60.
Good. Then each angle will be 60. If they tell you it's equilateral, you know it's equiangular, you know the angles are 60. Period, end of story. Write it on the paper. You with me?
I got you.
So I'm going to give you a second, and I want you to try number 6. Okay? So it says that triangle EFG is equilateral. What does that mean?
All the angles are the same.
All the sides are the same.
And all the angles are the same.
What are the angles going to be?
6 equal angular.
Good. 60, 60, 60, right? Then it says that EH bisects, and you just told me that EH means that it cuts it in half.
30.
What is it cutting in half?
The
Angle E.
Angle E. Well, here's angle E. How big is angle E?
30.
Angle E is 60, so if I cut it in half, it would be 30 and 30, right? Oh, so then EJ cuts angle HEG in half.
That's 15.
So each one of these are going to be 15, right? Okay. So it wants to know how big is HEJ. HEJ is how big? 15. Very good. Then it says, well, how big is EJH? EJH is this angle right here. Remember, J is the vertex. It's in the middle, right?
It's going to be 30.
Nope.
You gotta equal
75.
Hey, this is a triangle, right? How big is a triangle? Good. So I have 60 and I have 15, which is 75. 180 minus 75 is 105. That means that this angle right here is 105.
And the other one is 70.
And this is a straight line, so these two have to equal 180. 180 minus the 105 is 75. Right? And then EJG is the 105. Okay, try the next one. So it told me that GH is congruent to MH, which means that these two angles down here are the same. And then it told me that HJ is congruent to JM, which means that these two angles are the same. It then told me that KLM is equilateral, which means that each angle is 60. And then it tells me that HMK is 50. I know that this has to be a straight line, so this has to equal 180. So 60 plus 50 is 110. 180 minus 110 is 70. That means this one is 70. This one is 70. That gives me